welcome to one of the Technical Grower Talks. Analytical services play an important role at Berger. The ability to do a wide variety of analysis allows Berger to be quick and proactive in regards to the quality of its products and to provide strong technical support to growers. The key word here is proactive. As a team, our technical support team and the salespeople try to stay on top of people's or customers' issues so that we could be, rather than be reactive, trying to correct a problem, we stay ahead of it to be proactive. Berger's laboratories perform a wide array of tests, quality control, several tests done for each production and on each component. So this type of quality control is for the production of the material and to assure that we are producing the highest quality that we can. Crop monitoring, that's services offered to customers. Complete mix characterization, match the product you are currently using to our growing media. Special analysis upon customer request. There might be where someone might want to know of a specific, say, metal or element in the mix, or is there one in the mix that is available. For instance, customers want to know now how much silicon might be in the mix. So we can do those upon customer's request. Routine quality testing. Every product and component goes through a stringent quality and control system. You have an incubated pH, a 1-day pH, then a 7-day and a 30-day. The 7-day is very important. We try to make sure that the 7-day is already moving towards our guaranteed targeted pH for the mix upon delivery. So we follow that 7-day. And again, a 30-day is just to see if the pH after the 7th day is going to drift too high or drift too low. And so it gives us, in 30 days, we know what to expect in the lab under just one unaltered condition of distilled water. Electrical content, so the EC, particle size, root content, density and moisture content, saturated media extract, and wettability. Berger's quality control ensures stability, consistency, and traceability. The results of a quality control are used to produce the final inspection report. You have the SME, so a total analysis of all the macro and micronutrients that are produced by the charge that is put in the initial mix. We have the incubated pH, and again, the important pH for us is that at 7 days, in this case, it reached its values its optimal values that we were targeting. And then when I said particle size, we have the number 10. We use the number 10 as the coarseness for the peat. Okay, so are you familiar with like sieving? Okay, so we'll have a 3/8, we'll have a 10, we'll have a 20, a 50, a 100, and 200, but it's the percent that is on the number 10 that dictates if we are getting, for that designated mix, we are getting the actual 10 mesh size that will help and assist in the aeration and the porosity of the mix. Okay, and then last is the water content. The water content actually of the peat in a compressed state when it leaves in the format that we pack, whether it be a 3 cubic foot loose in our 3.8 or even in our tower or sky. Berger has detailed information. Coupled with products traceability, this quality testing allows Berger to provide consistent and high quality product. When we say traceability, FARs are always available to the customer on the actual package, like say whether it be a 3.8 or whether it be sky. There is a barcode and there is a number where then if that's scanned, it actually brings us exactly to the date, to the peat, and at what time it was actually made on the line. Crop monitoring, a great grower tool. high quality growing media to initial step towards a successful production. However, it is the grower's responsibility to maintain this quality during production. Berger's laboratory can provide the tools necessary to help monitor crops throughout the production cycle. So we're always hoping that the grower is going to do some type of routine EC and pH just to see if he's within his expected ranges or what he is expecting. And then what we do then is that you might want to say that the crop's looking really good. I'd like to get a full SME analysis done of it to see how my fertility is working, how my fertilizer program is working. And so we can provide the tools necessary to help monitor crops throughout the production cycle. Crop follow-up SME analysis. Verify if the media pH and EC are optimal. Quantify the nutrient content. Are my crops over-fertilized? Are my crops hungry? Unlike many other quality control tests, the SME can be done on used and unused media. If you're testing the pH and EC in-house, send a sample to our laboratory once in a while to make sure your equipment is actually calibrated properly. It is very important if you're doing a lot of in-house testing that you are aware of how to calibrate and how to clean. And then it's also very important to do that on a routine basis to make sure that for your own sake, you are getting proper readings. Different methods, same information. So most labs, they will do an SME, okay? You can see the process. It's basically like a 1-to-1, and it's saturated. It sits for 2 hours, and then you can measure the pH directly in the paste, but then you extract the leachate for further testing, including the EC. Okay. Pour through. A lot of in-house testing people do use the pour through. You irrigate container and wait for 1 hour. Pour distilled water over the substrate. Collect the 50 ml of leachate. Then you measure. The only important thing here is the fact that if you're going to start using the pour through, you do the same routine week after week. So if you started to do this testing on a Tuesday after 3 hours of leaching or fertilizing, the very next Tuesday you do the same type. People will tell me often that they do use the pour through method, but they've modified the pour through method. When you modify it, then you're not going to really get the same readings, because I think you're aware that the actual analysis will go in as we go through. You're going to see that they do read differently. Then the 2-1 is the conventionally old spurway method. Used to be used all the time. It was used a lot when we actually had field soil mixed into the peat-lite mixes. It's still very, very good to use, and does give you a very good reading. But the results will differ between methods. There are conversion factors to be used so that we can compare the results. Because many times someone will send us in a sample and they've just said that I've just done my tests and they don't coincide with your readings. And then we have to figure out which one they used, and we ask them that. And then we can then say we can compare by just converting and seeing if we are all within the same ballpark range. Okay. Saturated media extract. At Berger, the leachate is always analyzed to quantify macro and micro elements: nitrates, potassium, sodium, manganese, aluminum, ammonium, calcium, iron, zinc, molybdenum, phosphorus, magnesium, copper, boron, and sulfates. And again, the new test is silicon can also be tested on demand. Crop followed up tissue analysis. Both healthy and unhealthy plant samples should be sent. And I guess we have to reclassify the unhealthy. Most of the time we're looking at something that's really lacking in nutrient. If something has a severe disease, most of the time if someone even tries to take that diseased leaf and send it to us, by the time it gets to the lab, it's totally disintegrated. It's just broken up and turned into water. So it's of no use to us. So when we say unhealthy, I think the better word would be a well-fed and a poorly fed, and you're wanting to know why this plant is nice and healthy and green, and this one is having a lot of what we would call deficiency symptoms. Okay. How it helps to identify nutrient deficiencies or toxicities. I must say that always, again here, when you're going to send the sample, make sure that your root system is in very good healthy condition. For instance, we go and turn over this unhealthy plant and we find that all the roots are already dead on it, been killed by high salts or something else. Then the thing is that the actual readings we're going to get are going to be totally skewed because the plant hasn't been able to take up nutrients at all because the roots aren't there. Okay. Give the best indicator of the availability of the nutrients. Nutrients present in the growing media may be unavailable to the plant. Our experts can provide reference values for several crop species. Send a sample of your healthy crop that you produce every year to establish a baseline. You will then have the best reference values for one day. If one day your crop develops a problem, here we go, give the best indicator of the availability. Nutrients present in the growing media may be unavailable. They may be unavailable to the pH. pH may be too high, pH may be too low, but they also may be unavailable to nutrient antagonisms. Certain nutrients, if they're too high, won't allow other nutrients to be taken up by the roots. Okay, so the analysis then can always give us a good idea, because 90% of the time when I have a hungry plant, it's not due to an actual nutrient deficiency, it's due to a tie-up by something within the root ball itself. Crop follow-up, water nutrient solution analysis. Water quality has a great impact on crops. High alkalinity will increase soil pH. Inadequate EC can impair plant growth. Moderate water alkalinity can be managed with the right combination of fertilizers, but some cases may require acid injection. And it's good to see the word moderate water alkalinity, because many of the research done on using an alkaline, a basic or an acidic fertilizer to control alkalinity have found that you pretty well can start with that practice if you're in a moderate level. Say if you're at 120 to up to 180, okay? But if you're starting with 300 and plus, you know that your best bet is start with the acid injection and then coordinate the difference between, or switching and alternating of basic and acidic fertilizers. Whether water comes from the city, a well, or an aqueduct, its quality is influenced by several factors like droughts and abnormal precipitation. Tip for success: regular water testing about once every season helps to anticipate and quickly manage any variation in water quality. Crop follow-up, sending sample. For an SME, at least 2 cups, 500 mils of growing media is required. Place the sample in preferably a Ziploc bag, but a bag that's going to be sealed. Okay. For tissue analysis, at least 500 mil, 2 cups of plant tissue is required. Place in a paper bag. Definitely, if you've taken those leaves during the heat of the day, when you know that the field temperature of those leaves is going to be high, it's probably good to put them in the shade, put them on a paper towel, let them dry up. Because I've had, even putting them in a bag, I've had material that was taken on when the leaf temperature was 90 degrees, 100 degrees, and it still will break down. You just haven't let it cool down, so all the water's condensing and just bakes it and creates another situation. Water sample, at least 1 cup of water or nutrient solution is required. Place in a clean plastic bottle. If you don't have, I can emphasize the word clean. Rinse it several times, okay? Even the approach of a water sample is, at the end of the hose, is to let that hose run for a while, and even just for plain water to get a good sample. Complete characterization, at least one cubic foot of material is required. Complete characterization would be, we'd go back and do an SME, we'd actually do the particle size, we would do other tests involved in giving you a total physical and chemical characterization. So that's why they're asking for that much material. Tips for success. Sampling methodology is critical to get reliable results that are easier to interpret. For more details on optimal sampling procedures, please contact Technical Services Department. Complete characterization. When Berger's R&D department develops a new product, it undergoes many tests before it's released on the market, including a complete characterization. So in this case, we're actually going to do a quality test, whether it be leaf size, number of leaves, number of flowers, earliness to flower, bench run flowering. We will assess that to see if it does, then our product is doing what we would want it to do in the hands of a grower. Besides the usual tests, samples are submitted for water retention curve, total porosity, airspace, easily available water, water buffering capacity, and unavailable water. Hydraulic conductivity, see how much or how good that deep pot, especially if it's on a sub-irrigation, does it have good adhesion and cohesion to draw the water to the top of the pot, or just come up halfway, okay? Greenhouse trials, which we basically, besides our own greenhouse trials, we always get growers involved in trials, especially if they want to, if they're using our product, they want to try a new product, then we establish new trials to see how they're going to work, because outside trials are just much more beneficial than our own inside internal trials, because once the soil leaves Berger, you yourself as a grower, you know that it becomes very subjective. A lot of things that we do in the greenhouse can change its performance, okay? So it's good to see how the grower handles it. These tests can only be done on unused media. So fresh out of the bag, if you're having an issue where it's already in the pot and the person says, I still want this test done, the only problem is that once the soil is in the pot and once the roots are growing, it performs aggregates or clumps. So that when we go to do it on used media, our actual particle size would actually then be greatly skewed, because everything is clumping together, so it'd make it look like it's either bigger. Most of the time, there's much more on fiber. And so, yeah, because of what used material can do and how they can skew the answers, we have to just use unused media. Okay, so upon customer request, several other tests can be done. We will use the Malic 3 soil analysis, especially if a person says, I got 20-30% soil in my mix. Or even if a person says, I'm thinking of switching over to a peat-light mix, I still use soil, can I still have my soil tested? Because then we have to use this, because the Malic 3 will not work, or it will be skewed if we're just using a straight peat-light mix. Lime analysis, neutralizing capacity, particle size, etc. Fertilizer analysis, and many more. Berger's experts are always available to help customers select the appropriate analysis and interpret the results. If other analyses are needed, they will refer to you for the best external laboratories. And what we do basically is that most of your SMEs are going to have a very generic max and min, okay? The thing is that then we go one step further and we then say, for instance, we'll know what the max and mins should actually be for poinsettias. So then we'll be able to focus in, if someone says that it is poinsettias, we can focus in on the EC, the pH, the max and mins of all the nutrients, and put them within what a poinsettia is used to. Whether for quality control or crop monitoring, Analytical services offer peace of mind to Berger customers. We strive to provide consistent product for uniform results, help customers throughout their production via crop monitoring, and strong technical support.